Good evening, class. My name is Stewart Wells, and I'm going to be taking you through problem 103 of label section 1.4 tonight. It's a mixing application problem, so yeah, let's have some fun. Suppose a water tank is being pumped out at 3 liters per minute. The water tank starts at 10 liters of clean water. Water with toxic substance is flowing into the tank at 2 liters per minute with a concentration of 20 grams per liter at time t. When the tank is half empty, how many grams of toxic substance are in the tank, assuming perfect mixing? Alright, so let's start by writing down what we know from the prompt. Contents are being pumped out at 3 liters per minute. And then there are initially 10 liters of clean water. And then contaminated water is being pumped out at 2 liters per minute with a concentration of 20 grams per liter. Alright, so considering what we're starting with, we can now write our differential equation, which is going to be dA dt is equal to the rate in minus the rate out. Here the rate in is going to be 2 liters per minute times the concentration of 20 grams per liter. Which simplifies to 40 grams per minute. All right, then the concentration at time t is going to be A of t, the amount of the toxic waste over the original amount plus the change in the amount with respect to time. So it's going to be 2 coming in minus the 3 going out, t, which simplifies to A over t over 10 minus t. So the amount of the contaminant with respect to time over the amount of water. And then R out is going to be 3 liters per minute times the concentration at time t. So A of t over 10 minus t, which is 3 A of t over 10 minus t. Alright, and then this can be combined to dA dt, or the rate with which the amount of the toxic substance changes with respect to t, is equal to 40t minus 3 AT over 10 minus t. And then we can start to solve this with substitution. Okay, now adding this term to both sides, we get dA dt minus 3 A of t over t minus 10. So putting this in a different form equals 40t. So P of t is going to equal negative 3 over t minus 10. And mu of t is going to be e to the p of t, so minus 3 over t minus 10 dt. And this is going to become e to the negative 3 ln t minus 10, which becomes 1 over t minus 10 to the third. So this is our mu of t. We're going to multiply that through to both sides of our equation over here. So dA dt over t minus 10 to the third minus 3a of t over t minus 10 to the fourth. That's going to equal 40t over t minus 10 to the third, once again. And then considering that d dt of 1 over t minus 10 to the third is equal to negative 3 over t minus 10 to the fourth, which is this term right here. We can apply the reverse product rule. So d dt equals 1 over t minus 10 to the third times a of t. And this is going to equal 40t over t minus 10 to the third. And from here we can integrate both sides. Okay. All right, I'm going to integrate this term over here to save space. So we're starting out by bringing the 40 out. And then u is going to be t minus 10. du is just going to be dt. And then solving for t, we have 10 plus u. So putting all of this together, we have 40 then this can be broken up once more. So we'll have 40 times the integral of 10 over u to the third du plus 40 times the integral of u over u cubed du. So we have 400 times the negative 1/2 u over u squared minus 40 over u plus c. Substituting u, we get, it simplifies to 40t minus 200 over t minus 10 squared plus c. And we'll bring that back over here. All right, so after integrating, we are left with a of t over t minus 10 to the third, and that's going to equal 40t minus 200 over t minus 10 to the third squared, sorry. All right, multiplying both sides by t minus 10 to the third yields a of t equals, oh, this is plus c, sorry. It's going to be c times t minus 10 to the third minus 40t squared plus 600t plus minus 2000. Yeah. And then considering that the initial 10 liters of fresh water has 0 contaminants. Our initial conditions are going to be 0, 0. So A of 0 equals 0. And then using that, we can solve for C. So solving this, C is equal to -2. And then considering that the amount of water in the tank is represented by the expression 10 minus T, and that we're looking for the amount of toxic substance when there's 5 liters in the tank, or half of the tank, we're going to set this equal to 5, and T will be 5. So A of T is going to be -2 times 5 minus 10 to the third minus 40 times 5 squared plus 600 times 5 minus 2,000. This is going to be 250 minus 1,000 plus 3,000 minus 2,000, which is going to equal 250. So we will have 250 grams when there is 5 liters in the tank. There we are.